Good morning students. Exercise 12.1 fifth problem, first subdivision. Define an operation asterisk on Q as follows. A asterisk B is equal to A plus B by 2 where A comma B belongs to Q. Examine the closure, commutative and associative properties satisfied by asterisk on Q. So Q is nothing but a set of all rational numbers. Here the asterisk is defined in such a way that A asterisk B is equal to A plus B by 2. If you consider A is the first number and B is the second number, if you apply the asterisk between them means what you have to do? You have to add the first number and the second number and you have to write divided by 2. So therefore, you have to examine the closure, commutative and associative properties. So I'll go for the closure. So for that I have taken two elements from the set. What is the set? It is a rational number set. So let A comma B belongs to Q. Then I'm going to apply the operation. What is the operation? Asterisk. So what is the asterisk between A and B? It is nothing but A plus B by 2. So here we are getting this answer A plus B by 2 and you have to show that it belongs to Q. So you know very well, you look at the numerator A plus B. So here A comma B, these two are A and B. They are rational numbers. So we know that the sum A plus B is also a rational number. So A plus B by 2 is also a rational number. So it belongs to Q. So the answer is unique and it belongs to the same set. So therefore A asterisk B belongs to Q. So therefore Q is closed on the asterisk, or asterisk is called the binary operation on Q. Next we are moving to the commutative property. So commutative property, what it is? A asterisk B is equal to B asterisk A. If they are equal, we can say the asterisk is commutative. So commutative, for that first you are going to take the left hand side. What is in the left hand side? It is A asterisk B. So A asterisk B. How you can write? A plus B by 2. So what is the right hand side? It is, you have to interchange A and B. So it is B asterisk A. B asterisk A means what? It is B plus A by 2. You see that both are equal. So left hand side is equal to right hand side. That is A asterisk B is equal to B asterisk A. If this condition is satisfied by this operation, so the operation is commutative. Next we have to go for associative. For associative we have to take three elements. So let A comma B comma C belongs to Q. So what is associative? A asterisk B asterisk C is equal to A asterisk B asterisk C. So first left side I have taken A asterisk B asterisk C. Okay, so this term is within the bracket. So first we have to evaluate. So asterisk is applied B and C. So here in the definition of the asterisk, you have to write the first number plus the second number divided by 2. So it is B plus C by 2. Okay, now what you have to do? You have the asterisk is now between A and B plus C by 2. Okay, this is your first number. Which is your first number? A is the first number and your second number is what? B plus C by 2. So according to the definition of the asterisk in the problem, you have to write the first number plus the second number whole divided by 2. So what you are coming? A plus B plus C by 2 whole divided by 2. Okay, so if you take LCM, it is 2A plus B plus C by 2 and by 2. So it is nothing but divided by 4. So left hand side answer is 2A plus B plus C by 4. And coming to the right hand side, it is A asterisk B asterisk C. So A asterisk B means what you have to do? First number plus second number divided by 2 I have written. Now the asterisk is between this first number and this second number. Okay, in between what you are having? It's an asterisk. So what is the definition of the asterisk? So you have to write the first number plus the second number whole divided by 2. And if you take LCM, it is A plus B plus 2C by 4. You look at the left hand side. It is 2a plus b plus c by 4. Here a plus b plus 2c by 4. They are not equal. So therefore the asterisk is not associative on Q. Okay, we'll come to the second subdivision of this problem. Define an operation asterisk on Q as follows. A asterisk b is equal to a plus b by 2, where a comma b belongs to Q. The same way it is defined. Examine the existence of identity and the existence of inverse for the operation asterisk on Q. Okay, what is the identity property? So identity property is, already we have known, a asterisk e is equal to a. Otherwise, if you interchange, E asterisk A is equal to A. Okay, this is your identity property. And we have seen the theorem also. The identity element is unique for the set, non-empty set along with the operation. Okay, so I'll take the existence of identity. For that, I'll take the element A, the identity element E. So, A comma E belongs to Q. Okay, so what is A asterisk E? A asterisk E, according to the definition, it is A. Okay, so A asterisk E, if you apply the definition of the asterisk, it is A plus E by 2. That is equal to A. So A plus E is equal to 2A. From this, if you find E is equal to 2A minus A. What is 2A minus A? It is A. Okay, if you interchange, E asterisk A is equal to, what is it? A. And if you apply the definition of the asterisk, it is E plus A by 2 is equal to A. If you cross multiply, E plus A is equal to 2A and E is equal to 2A minus A. That is E is equal to A. Here also you are getting E is equal to A. But you see that if you consider A as 2 means the identity element is 2. Because E is equal to A. If A is 3 means the identity element is 3. If the element changes, so the identity element also changes. But according to the uniqueness of identity, for all the elements in the set, the identity element is unique. Okay. So therefore, here the identity element is not unique. It changes according to the element changes. So therefore, identity does not exist on Q for asterisk. Okay, existence of inverse, the next one. Identity does not exist. So existence of inverse, while you are talking, what is the inverse property? A asterisk A inverse is equal to E, or A inverse asterisk A is equal to E. Here the answer, we have to get the identity element, isn't it? Here the previously we have said identity element does not exist means, so we can't find the inverse also. So therefore, since identity does not exist, inverse also does not exist. Sixth problem, fill in the following table so that the binary operation asterisk on A is equal to ABC is commutative. Okay, so here the table is given, it is called K-list table. Here the operation asterisk, it is defined on the elements A, B, C. So in the column row wise ABC is written, the column wise ABC is written, and here some answers are written in the table. What is given? The binary operation asterisk on A on non-empty set is commutative. So the binary operation on the set A is commutative. So commutative means what? A asterisk B is equal to B asterisk A. Okay, so if you interchange the elements, both are getting the same answer. So here A asterisk B is equal to B asterisk A. Go for A asterisk B, that we have to find out. Then B asterisk A. What is B asterisk A? You have to see in the column B, and in the row you have to take the second element A. So B asterisk A, that is equal to C. If B asterisk A is equal to C means A asterisk B is equal to C. Why? In the binary operation is commutative. So A asterisk B is equal to B asterisk A. So therefore here you have to write C. Next also you consider the elements A and C. Okay, so the asterisk is binary operation is commutative. So A asterisk C is equal to C asterisk A. So which one you have to find out? A asterisk C has to be found. So for that, which is equal to C asterisk A. So the C you have to see in the column. So here C is here and A is in here. So C asterisk A, the answer is A. So C asterisk A is equal to A means A asterisk C also A. So these two elements we have filled. What is the next one is left out? This is nothing but C asterisk B. So C asterisk B, if you want to find out, so you have to look at the answer for B asterisk C. Why? Because this binary operation is commutative. So B asterisk C is equal to C asterisk B. Okay. What is given here? B asterisk C. B asterisk C is nothing but A. Okay, so C asterisk B, that also A. So therefore we have filled this element is C and here it is A and C asterisk B is equal to A. So it is given that the binary operation is commutative. So therefore we have found the answer. Okay, we'll come to the next problem, 7th problem. Consider the binary operation asterisk defined on the set A is equal to small a, b, c, d by the following table. So the table is given. Okay, so the operation asterisk is defined on this set A, B, C, D. So you have to find out, is it commutative and associative? So we have to check the property of commutative and associative for this non-empty set with respect to the operation asterisk. Okay, so for commutative, how many elements you have to take? You have to take 2 elements. So let A comma B belongs to A. You can go for C and D also. So here I have taken A comma B. Okay, so commutative means first you have to find out A asterisk B. So go for it. In the column you take A and in the row you have to take B. So A asterisk B is nothing but C. Okay, what is it? A asterisk B is C. Okay, which should be equal to, what is it? B asterisk A. So B asterisk A. So that is D. So they are not equal. So therefore this asterisk is not commutative. Next we have to check the associative. For checking the associative we have to take 3 elements. A, B, C belongs to A. Okay, so first in the left hand side what you should have? A asterisk B asterisk C. So first we have to find, you have to evaluate the bracket terms. What is the bracket terms? B asterisk C. Okay, what is it? B asterisk C. So from the table you look at your B asterisk C. What is it? It is nothing but B. What is? B asterisk C is equal to B. So here it is written. Next, what is asked? A asterisk B. Already we have written A asterisk B is C. So therefore final answer is C. So left hand side is over. We'll come to the right hand side. So first we have to associate A and B. That answer has to be associated with C. What is A asterisk B? Just now only we have seen it is C. C asterisk C. So in the column you have to take C and asterisk C. C asterisk C. So C asterisk C is which one? This element. Okay, here you are having A. Okay, so see here your answer is C. Left hand side answer is C and the right hand side answer is A. So therefore they are not equal. So asterisk is not associative. So we'll come to the 5-mark problem, important one, that is 9th problem. If M is equal to the set of all matrices 2 by 2 matrices of the form x, where x belongs to R minus 0, and let asterisk be the matrix multiplication. Determine whether M is closed under asterisk. If so, examine the commutative and associative properties satisfied by asterisk on M. So first we take the set. So what is M? The set name is M. So how the elements are in the set M? It is a matrix. What type of matrix it is? It is a 2 by 2 matrix. Not only that, the 2 by 2 matrix having all the elements are same. So the element belongs to r minus 0. So what is r minus 0? It's a non-zero real number. It's a real number, but it should not be equal to 0. So you see the M set having the element 2 by 2 matrix, having the matrix having all the entries are same. So that entry is a non-zero real number. Here asterisk. Here what is asterisk? It's a matrix multiplication. So first we have to check the closure, because determine whether M is closed under asterisk. So the question is asked. So we have to go for proving the closure property for the set under this operation asterisk, that is matrix multiplication. So closure means what you have to do? You have to take two elements. So two elements from the set. So M is the set having the element 2 by 2 matrix. So I have to take the element as matrix. So first element is the matrix x, 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 x. The second element is y, 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 y. Both the matrix belongs to M. If it's so, the entry x comma y, how they are? They are non-zero real number. Okay, so after taking the two element, you have to apply the operation asterisk, that is matrix multiplication. So you know how to multiply the matrix, two matrices. So take the first row and the first column, x into y, xy plus xy. So xy plus xy is 2xy. In the same way, first row, second column, you will get 2xy. And the second row, first column, it is 2xy. First row, second row, second column is also 2xy. You look at this element. It is a 2 by 2 matrix. All the elements, all the entries are same. And what we have to prove? The entry, how it should be, it belongs to a non-zero real number. You look at your x and y are non-zero real numbers. That means x is not equal to 0 and y is not equal to 0. So x is not equal to 0 and y is not equal to 0 means your xy should not be equal to 0. So it is 2xy is also a non-zero real number. So the 2xy, how it is? It belongs to r minus 0. So see that this entry, how they are? All the entries are same and it is a 2 by 2 matrix, and this entry is a non-zero real number, means this element belongs to M. So this is the answer for which one? XXX asterisk YYY matrices, the product of these two matrices. So these two belongs to M. So we have taken two matrices from the set and we apply the binary operation. This answer also belongs to the same set, means the set is closed under asterisk or the operation is a binary operation. In the question, the second one, if so, if it is closure means, if so, examine the commutative and associative properties satisfied by asterisk on M. So we have to go for commutative. So commutative means what? A asterisk B is equal to B asterisk A. Okay, so what is that commutative property? A asterisk B is equal to B asterisk A. So first we have to take the left side. Left hand side, what we have to write? Usually we will write A asterisk B. Here the element are in the matrix form. So we have to take two elements, two matrices. One is a XXX matrix, another one is a YYYY matrix. So left hand side. So first we have to multiply these two. So your answer is 2xy, 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 2xy. Because first row, first column, first row, second column. In this way you have to multiply. So what is the right hand side? You have to interchange the two matrices. If you interchange and multiply, what has to come? Yx plus yx, that is 2yx. 2yx and 2xy, they are equal. So see the left side and the right side, they are equal. So therefore A asterisk B is equal to B asterisk A. So therefore it is commutative on the set M. Next we have to check the associative property. So for the associative property, you have to take how many elements? 3 elements. So 3 instead of here, the elements should be in the form of a matrix. So I have considered 2 by 2, 3 matrices. So one is having the entries x, 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 and the second one y, 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 and the third matrix having the entries z, 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 z. All the 3 matrices belongs to M. How to associate? First we have to associate the second and the third. Okay, and that answer has to be associated with the first. So therefore the first matrix is written and we are going to multiply these two, because asterisk is what? It's a matrix multiplication. So we are going to multiply these two. So when you multiply, what has to come? YZ plus YZ, that is 2YZ. In the same way you will have all the entry. First row, second column also 2YZ. Second row, first column also 2YZ. And second row, second column also 2YZ. So this is the first one, and in between you are having asterisk with the answers of the second and the third matrices. That is the answers of the product of the second and the third matrices. Now we have to multiply these two. Why we have to multiply? Because in between you are having asterisk. So asterisk here in this problem is a matrix multiplication. So we have to multiply these two matrices. Take the first row and the first column. X into 2yz is 2xyz plus x into 2yz, that is 2xyz. So if you multiply and add, you will get 4xyz, 4xyz, 4xyz and 4xyz. This is the answer for the left hand side for the associative property. Next what we have to do? We have to go to the right side. For the right side, first and the second matrix has to be associated first. So if you multiply, because asterisk is matrix multiplication, you will get the answer as what? 2xy, 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 2xy. Asterisk, the third matrix, x, 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 x. So how to multiply? 2xy, the first row, first column. 2xy into z, that is 2xyz. Plus 2xy into z is 2xyz. So what's the answer you're getting? 4xyz, 4xyz, 4xyz and 4xyz. So you call as 2. So from 1 and 2, how they are? A asterisk B asterisk C, which is equal to A asterisk B asterisk C. So therefore this matrix multiplication is associative on M. Otherwise I have written asterisk. Asterisk is we have defined already, it is a matrix multiplication. So asterisk is associative on M. And coming to the the second subdivision, the same thing. Let M be a set of all matrices of the form 2 by 2 matrix of the form x, 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 and where x belongs to r minus 0. And let asterisk be the matrix multiplication. Determine whether M is closed under asterisk. If so, examine the existence of identity, existence of inverse property for the operation asterisk on M. So already in the previous subdivision we have proved M is closed under asterisk. So that's why I didn't write here. If the second subdivision alone is asked, so first we have to prove the closure property, then we have to move to the existence of identity and existence of inverse. So it is we have proved in the first subdivision. So I am moving to prove existence of identity. So you know that what is the identity property? So if you consider the any element A asterisk E is equal to A, isn't it? Okay. So otherwise if you interchange E asterisk A is equal to E. Here the element is A. Here now the element are in the form of a matrix. So first you have to take one element. What is it? X, 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 X. It's a 2 by 2 matrix. That is belongs to M, and where X is a non-zero real number. Okay. So first I'm going to use the definition of the identity. What is the definition of the identity? A asterisk E is equal to A. So here, instead of A, we have to take a matrix. What is it? X, 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 X. And how the identity element also, this also a 2 by 2 matrix having all the entries are same, and that entry is a non-zero real number. It should be like that, then only E belongs to M. So for that I am going to find out such a element. So I will consider the matrix E, 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 E. Okay, so according to the definition of identity, what has to come? The same thing, same matrix, what you have taken, it has to come. So therefore the answer is X, 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 X. So here I have used the definition of identity. What is it? A asterisk E is equal to A. So therefore this matrix asterisk, the identity matrix is equal to the matrix itself. Okay, the same thing you take and you have to use the definition of asterisk. Here what is that? How the asterisk is defined here? It is a matrix multiplication. So you have to multiply these two matrices. While you are multiplying, what has to come? XE, XC plus XE, XE. So therefore it is 2XE. So all the entries having 2xe, 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 2xe. So see the left hand side, they are equal. So how the right hand side should be? Right hand side is also equal. So therefore I am going to equate these two matrices. About 2xe, 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 2xe is equal to X, 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 X matrix. Okay, if the two matrices are equal means the order should be same and the corresponding entries has to be equated. So here the entry is 2xe is equal to X. Here which one we have to find? Identity element. So E is equal to X by 2X. So X, X getting cancelled, you are having 1 by 2. So 1 by 2 is a element. Okay. It's a number. So it belongs to R minus 0. It's a non-zero real number. But what should be the identity element for the matrix? So it is, we have taken the matrix E, 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 E. Okay. So therefore 1 by 2, 1 by 2, 1 by 2, 1 by 2. This only belongs to M. That is the identity element of the matrix. Okay, so next one we are moving to the existence of inverse. Okay, so we have to take the element XXX. Okay, this matrix 2 by 2 matrix having the entries X belongs to M, where X belongs to the non-zero real number. Here we are going to use the definition of inverse. So what definition we are going to use? Inverse definition. So if you consider the element as A, whose inverse, if you denote A inverse, what the answer you should have? It is E. That is the definition of inverse. So A asterisk A inverse is equal to E. Here our element is as a matrix. So we will consider the matrix X, 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 this matrix, asterisk. How A inverse? If A inverse should belongs to M. So therefore all the entries should be same. So I'll take X inverse, X inverse, X inverse, X inverse. So I have denoted the inverse like this. Inverse matrix is this. Is equal to E. So it's also a matrix. How it should be? E, 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 E. See that? Here the entry, here your entry is a matrix. So instead of A, I have taken 1, 2 by 2 matrix having all the entries are same. And here A inverse is a inverse element of A. So here I have considered a matrix. This is the inverse of this matrix. So E is equal to, what has to come? It's an identity element. So it is a identity matrix. That is E, 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 E. That matrix. Isn't it? So here we have the result we have proved this is the identity element. Which one? matrix having the entry 1 by 2. So E in the place you have to write 1 by 2, 1 by 2, 1 by 2, 1 by 2. You see now, by the definition of inverse, A asterisk A inverse is equal to E. So here your E identity matrix is this one for this problem. So we are here yet. So we have taken the same elements. Now you are going to apply the definition of asterisk. So what is asterisk? It's a matrix multiplication. So we have to multiply these two matrices. So first row, first column, x inverse plus x inverse. So you will get what it is, 2x inverse, 2x inverse, 2x inverse, 2x inverse. You see the left side, they are same. So the right hand side should be equal. So therefore these two right hand side matrices are equal. So if the two matrices are equal means the order should be same and the corresponding elements should be equal. So you take the corresponding element. So 2x inverse is equal to 1 by 2. Here you are going to find x inverse. So x inverse is equal to 1 by 2. The 2x, where it has to come in the denominator. So 2 into 2x is 4x. It's a number. So this number is a non-zero real number because x is a non-zero real number. If x is 0, the x inverse does not exist. So x where it is, we have taken it's a non-zero real number. It should not be 0. So therefore 1 by 4x also non-zero real number. So but inverse matrix is what? 1 by 4x, 1 by 4x, 1 by 4x, 1 by 4x belongs to M is the inverse of x matrix. Okay. So in this problem the element should be in the form of a matrix. And we'll come to the problem number 10. First subdivision, let A be Q minus Q bar set 1. That means it is Q excluding 1. That means excluding 1 means the 1 is not included in the set. So it is Q minus the number, the set 1. Okay, define asterisk on A by x asterisk y is equal to x plus y minus xy. Here the asterisk is defined between the two numbers x and y in such a way that x asterisk y is equal to x plus y minus xy. So first you should know about the definition of asterisk. So see now, x is the first number and y is the second number. If the asterisk is applied between the first and the second number means first number plus second number minus the product. So you have to write the first number, then you have to write plus, and you have to write the second number, then you have to write minus, and you have to make the product of those two. So x plus y minus xy. So is asterisk binary on A? So if so, examine the commutative and associative properties satisfied by asterisk on A. So first we have to check the operation defined is a binary or not. Okay, so first we will take the set. What is its name? Whose name is A. What is A? It's a set of all rational numbers except 1. So 1 தவிர மீதி எல்லா rational numbers இந்த செட்டில் இருக்கும். So A is Q minus the set 1. So therefore A is a set of all rational numbers except 1. And asterisk is defined as x asterisk y is equal to x plus y minus xy. Okay, so yes, asterisk is binary. So binary operation, and we can say the set is closed. So I'll go for closure. So for closure you have to take two elements. So I'll go for x comma y. Okay, belongs to the set. Because it's not a matrix, it's a rational number. So I'll take x comma y belongs to A. So belongs to A means x is a rational number, y is also a rational number, but both should not be equal to 1. So that's why here I have written x is not equal to 1 and y is not equal to 1. Okay, and what you have to prove? You have to apply the asterisk between the operation. You have to apply between x and y. So what is the definition of this asterisk? First number plus second number minus the product, so minus xy. So see that we have to show this answer also belongs to A. If this answer belongs to A, how it should be? It should be a rational number, but it should not be equal to 1. Both the results we have to prove. What are both the results? That number is a rational number and it should not be equal to 1. So you know very well how x and y, they are rational numbers. So the sum x plus y and the product xy are also rational number. So therefore, I have proved x plus y minus xy is a rational number. Okay. So this answer is a rational number. And what we have to prove it? So it should not be equal to 1. So we have to prove that this answer should not be equal to 1. So we are going to prove this answer should not be equal to 1 by using the method of contradiction. So for that, we first will consider on contrary that element is equal to 1. So what we have to prove? This element should not be equal to 1. So for that, we are using the method of contradiction. So we are going to assume that that element is equal to 1. So here from the second and the third term, if you take y, it is 1 minus x, and bring this x to the next side, it is minus x. So this 1 minus x and this 1 minus x getting cancelled, you are getting y is equal to 1. So what we have taken, xy belongs to A means x is not equal to 1 and y is not equal to 1. Okay, so here we are at y is equal to 1. So y should not be equal to 1. So we are getting a contradiction for y is not equal to 1. Because we have assumed, we have taken this. So adukku contrary we are getting here y is equal to 1. So why this contradiction occurs? Because we have taken x plus y minus xy is equal to 1. So our assumption is wrong. If our assumption is wrong means which is the correct assumption? X plus y minus xy should not be equal to 1. So first what we have proved, this answer is a rational number and now we have proved it is not equal to 1. So the rational number which is not equal to 1, where it will be, it belongs to the set A. So therefore x plus y minus xy belongs to A. This is the answer for x asterisk y. So x asterisk y belongs to A. So for all x comma y belongs to A, x asterisk y belongs to A means your asterisk is a binary on A, or otherwise we can say the set A is closed under asterisk. So we have proved the closure property. So therefore the operation is a binary operation. So next we have to check the commutative. So for commutative, how many elements you have to take? 2 elements. Here we have taken as x and y. Both belongs to A. So first we have to take the left hand side. What is x asterisk y? What is x asterisk y? X plus y minus xy. Next we have to interchange the right hand side, y asterisk x. Now your first number is y and the second number is x. So first number plus the second number minus the product, so yx. You look at both are equal. So therefore asterisk is commutative on A. Now we'll come to associative. So for associative, how many elements you have to take? You have to take 3 elements. Okay, one is x, another one is y, another one is z. So we have taken 3 elements. So first we are going to find x asterisk, y asterisk, z. So first one, which one has to be evaluated? The bracket term has to be evaluated. So here asterisk is between y and z. So y is the first number and z is the second number. So you have to write the first number plus the second number minus the product, so y into z. Now here you see that x asterisk this number y plus z minus yz. Asterisk is in between x and this number. So your x is your first number and this number is your second number. You look at this now. Here x asterisk, what is it? Y plus z minus yz. Now this is your first number and the whole thing is your second number. So what is asterisk? A asterisk B. How it is defined in this problem? It is A plus B minus AB. So first number plus the second number minus the product. Okay, here the first number is X. Next we have to write plus. Okay, next you have to write the second number. What is the second number? It is Y plus Z minus YZ. I have written the second number. Next what you have to do? You have to write minus. So I put minus. Next you have to take the product of these two. So first number into second number. Your first number is X and the second number is Y plus Z minus YZ. Look at this answer. First number X, this is the second number, minus the product. So now what you have to do? You have to evaluate the product. Minus X into Y, so minus XY. Minus X into Z is minus XZ. Minus X and minus YZ is plus XYZ. So your answer is X plus Y plus Z minus YZ minus XY minus XZ plus XYZ. That is the left hand side answer. So we'll come to the associative property, the right hand side. So X asterisk Y asterisk Z. So you know very well, X asterisk Y, how it will be written? X plus Y minus XY asterisk Z. Now which is the first number? Look at your X plus Y minus XY. This is your first number asterisk Z. So this is your first number and this is your second number. So asterisk means what you have to do? You have to write the first number. So X plus Y minus XY. I have written the first number. Next plus. You have to write the second number. What is your second number? Z. Next you have to write the minus. Then the product of these two. So it is X plus Y minus XY into Z. Okay, so here I have written. So now what you have to do? You have to multiply these two. So X into Z, XZ. In between you are having minus. This minus is common to the three terms. So minus XZ minus X. What is it? Here it is minus YZ. So what is it? Here you have to get minus YZ. And minus into minus plus XYZ. So therefore arrange the single term X plus Y plus Z minus XY minus YZ. Here what has to come? Minus YZ minus XZ plus XYZ. You look at the same term you will have. X plus Y plus Z is there. Minus XY. Here you are having minus XY. Minus YZ. Here you are having minus YZ. Minus XZ. Minus XZ plus XYZ. How they are? They are equal. So therefore your asterisk is associative on the set given. What is the set? A. So it is asterisk is associative. So second subdivision. Let A be Q excluding the set 1. Define asterisk on A by X asterisk Y is equal to X plus Y minus XY. Is asterisk binary on A? If so, examine the existence of identity and existence of inverse properties for the operation asterisk on A. So the set is, it's a set of all rational numbers except 1. The asterisk is defined X asterisk Y is equal to X plus Y minus XY. So is the asterisk binary on A? We have proved in the first subdivision. We can make use of it. And here I am moving to the existence of identity. So identity means you have to go for, you have to take one element from the set. So I have taken X belongs to A. So first I am going to use the definition of the identity. So what is it? A asterisk E is equal to A. Here instead of A you are having X. So X asterisk E is equal to X. The same for these same elements you have to use the definition of asterisk. What is asterisk is defined here? First number plus second number minus the product. So first number is X and the second number is E. So first number plus second number minus the product. So it is XC. So see the left hand side they are equal. So the right hand side should be equal. So X plus e minus xc is equal to x. So from these two terms, if you take e as common, it is 1 minus x. Okay, so in the x, if you bring it to the right hand side, it is minus x. So x minus x is 0. So here e is equal to 0 by 1 minus x. 0 by 1 minus x is 0. So this 0 belongs to where? It is a because it's a rational number, it is not equal to 1. So therefore 0 belongs to a is the identity element. Next, existence of inverse. So I'll take one element, x belongs to a. Now we are going to use the definition of inverse. What is the inverse property? X asterisk x inverse is equal to e. Okay, what is your e? What is the identity element for the set? It is 0. Here I have written 0. So for the same elements x and x inverse, you are going to use the definition of asterisk. Asterisk definition in this problem is first number plus second number minus the product. So x plus x inverse minus x inverse. Okay, see the left hand side are equal, so the right hand side also equal. So therefore x plus x inverse minus x inverse is equal to 0. From these two terms, if you take x inverse out, it is 1 minus x. So the plus x, when you take it to the next side, 0 minus x is minus x. So x inverse is equal to minus x by 1 minus x. So if this element belongs to a, means your x, how it should be? It is belongs to a. X belongs to a means x is not equal to 1. So if x is equal to 1, what will come here? 1 minus 1, 0. The denominator is 0 means the inverse does not exist. So since x belongs to a, so this number belongs to a. So therefore, this is the minus x divided by 1 minus x belongs to a is the inverse of x. Thank you, students.